Hello all learners, welcome to the course of Metrology and GD&T approach. So in this course we'll deal with the basics and fundamentals of Metrology and GD&T. So myself Rohit Bhaskar, Assistant Professor in Mechanical Engineering Department, K.K. Wagh Institute of Engineering, Education and Research, Nasik. So in first session we'll be discussing to the introduction to metrology. So what part we'll be dealing with. So after what are the objectives of this course. So you'll be able to select an suitable instrument or a gauging method after studying this course, and you'll be able to determine the geometrical and dimensional measurements. Likewise, to calibrate measuring instruments and also design inspection gauges. What will be the outcome after learning this course? You will be learning the basics and you will be able to explain the limit, fits and tolerance and related geometrical positions. With that, you will be able to understand the different methods of measurements and standards of measurement. Likewise, you will be able to evaluate the problems and analyze the cause for the variation with the corrective methods. So with that, few of the reference I will be suggesting for this course. You can refer the basic engineering metrology book by Mr. R.K. Jain by Akhanna publication, or with that you can go with the I.C. Gupta metrology book, or another book or textbook we can call by Tata McGraw-Hill as metrology and measurements. So we'll be starting with our course. So initially we'll start with the part of metrology. So what does exactly metrology means? It means the measurement science. It is the derived word from the Greek, that is metro means measurement and science, that is logy. So metrology is nothing but the science of precision measurement. Now in this slide our concentration will be basically on the precision, to understand the precision and measurements. So measurement is nothing but defined as the process of numerical evaluation of a dimension or the process of comparison with the measuring standard. So in short, what we can say that the whatever numerical values we will be getting for any dimension, and it will be compared with the standards. So different elements may be the instruments, the calibration standards, or few of the environmental or human effort, or we can say the features of the workpiece. Before learning or moving towards the instruments, we'll be starting with the basic standards. So standards are basically classified based on calibration standard. So calibration standards is related with the working standard, or we can say the industrial or governmental laboratories. With that, metrology standards is nothing but the reference standards of industrial and governmental bodies. And third standard is nothing but the national standard, which relates the different basic prototypes and natural phenomena of SI international system. Now basically linear measurement is classified into three standards. We call it as first one as line standard, this one, second one as aim standard, and third one is nothing but the wavelength standard. So we'll be dealing this one by one. So what does exactly line standard means? So line standard is nothing but if we measure the difference between or the distance between the two parallel lines is called as the line standard. So what we can say that the example or good example is yard or a meter. To understand line standard, we can just simply use a measuring tape or a steel rule. So all these instruments comes under the category of line standard. So basic units are yard and meter. So from this slide we can remember yard and meter are the line standard. Likewise, end standard. End standard is nothing but the distance between the two surfaces. If you have to measure the distance between the two different walls, we can say that it will act as an end standard. So what is the example? We have length bars or we have sleep gauges. So these are the basic important two examples of end standard, and obviously we can say that these two are very highly accurate and it is made from bars of carbon steel. which will provide us a size of 10 to 1200 mm length and 20 mm diameter. So line end standard deals with the distance between the two surfaces. So basic classification, or we can say differentiation between line and end standard. So end standard is somewhat complex process because we require some sort of auxiliary equipments for understanding this, whereas line standard is very cost effective and a very simple process. But if we go with the errors, there is possibility of parallax error in case of line standard compared to the end standard. But as far as accuracy is concerned, it has a high degree of accuracy compared to line standard. Good examples, I told you, length bar or slip gauges and meter and yard. Wavelength standard. This is the third type of standard which totally differs from the line and end standard because it does not has any effect of variation in temperature, pressure or overall environment if we compare it with the earlier two standards, since it uses a monochromatic light source. So concentration is to be just 1 meter krypton light, that is 1 meter wavelength is equal to, or we can say that internal standard measures the meter in terms of wavelength of a krypton light. So standard relation we should remember as given in the book, it's 1 meter equal to 1650763.73 into wavelength of radiation. So timing we can remember, the wavelength standard relates with the light source. Now important part is the calibration. So calibration is nothing but bringing any type of a measuring system in accordance with the external authority, or what we can say is, so compare with the external authority such as standards. So what will be the steps? A good example is a balance. We are going to use the standard masses and relate those masses with that balance. So all the steps are to be followed in a lab. That may be an isolated lab, or we can call it as a metrological lab. So another term which is related, or we can say that interdependent with the calibration, is nothing but traceability. So traceability is nothing but the direct chain of calibration. So number of steps included together in the calibration process constitutes traceability. You have to trace any type of dimension, which is most probably given as a by NIST. What exactly it is? So how the dimensions are traced? We have a primary standard which is internationally based from internationally prototype, that is platinum iridium bar, which is in France. So we acts as a primary standard. So from that we trace a dimension and it is transferred to a national standards. So it will be called as a primary national standards, and from that national standards the dimensions are transferred and the commercial equipments or instruments are manufactured. So it is called as a secondary standard, and in this way final stage is the working standard. Whatever instruments related to measurement or metrology we are using in our day-to-day life are related with our working standard. So these are the following steps, one by one steps, which are followed over here. So it relates with the traceability. So traceability usually provides the information and standardization related to the instrument. Unless and until we don't have certification for any type of an instrument, it doesn't act as a standard. So certification is provided by national institutes. So that's why I told you traceability relates with the NIST. So NIST is nothing but the National Institute of Standards and Technology. So NBS standards are also present. So this is all about the traceability. So these are the basic concepts or terms which we have discussed in our first session. So we'll be dealing with the few of the next session, in which we'll be able to understand all the basic fundamentals of measurements and GD&T. So thank you. Move on to our next session.